Transformations. What is a transformation? A transformation is a way in which we classify the movements or changes of a line on a graph. A translation involves sliding the line from one position to another. A rotation involves turning the line about a point called the center of rotation. We must now distinguish between horizontal and vertical translations. For any parent function, f of x equals x, a vertical translation is given by adding some k value at the end of that expression. For example, if we put in plus 3 for k, our line now slides up 3 units. If we put in negative 2 for k, our line will slide down 2 units. Horizontal translations occur when you have your x variable in a parentheses with some h value. This time, however, a positive h means that x is actually lower, so the graph shifts to the left. Conversely, if you have a negative h value, the line shifts to the right. So for the function f of x equals x plus 1, if we put in plus 4 in parentheses next to our x, then we shift the line 4 units to the left. Also, if we put in minus 2 in parentheses next to our x, the line shifts right 2 units. Let's practice. Given the function f of x equals x plus 6, write the function rule for g of x, which is f of x translated 3 units downward. Think about the word downward. It refers to the up and down direction, so this is a vertical translation. And since upward sounds like addition, downward must be subtraction. So to move f of x down 3, we should subtract 3 at the end. We now have g of x equals x plus 6 minus 3. Solving this gives us g of x equals x plus 3. Now let's take a look at rotations. Using the parent function f of x equals x, we can identify a rotation by the slope of the new line. A rotation is a turn about an intersection that both lines still cross. The only thing that changes is the slope. For example, the new function f of x equals 2x has been rotated about the point 0, 0 from our original parent function. It now has a greater slope, so the line is steeper. We know the slope is greater because 2 is greater than 1. Remember that there is an invisible 1 in front of the x from our parent function. Another example is the function f of x equals half x. This has been rotated from our parent function f of x equals x because it has a smaller slope, meaning the line is less steep. This slope of half is actually less than 1, so the slope has gotten smaller or closer to 0. This rotation is still about the point 0, 0 because both equations share this point. Let's practice. We are given f of x equals 4x minus 3 and gx equals 2x minus 3. We are then asked to describe the transformation from the graph of f of x to the graph of g of x. Notice that the only difference between these two lines is their slope. The first has a slope of 4, and the second has a slope of 2. If you plug in a 0 for x into both equations, you will get the same value, which is negative 3. Therefore, this rotation is about the point 0, negative 3. And since we went from a larger slope of 4 to a smaller slope of 2, the new line is less steep.